Hello, everyone. My name is Philip Boyd, and this is my final project for the Managed Machine Learning's projects class provided by Duke University. I'm really excited to have learned so much in this class. This is the second course that I've taken under the specialization, and I've really enjoyed it. So, with that being said, I chose a real-world healthcare problem. And what made me think about this problem is I recently got an email saying that I was going to get fined for canceling or rescheduling an appointment I had within 48 hours. And I said, well, as I'm thinking about this class, what could health care providers use to predict when somebody was going to no-show? Even though I didn't no-show, I think that would be a valuable model for them to use machine learning for. So here's the steps that I took. Starting at number one, I did opportunity evaluation, aka missed medical appointments are a huge problem in healthcare. They lead to waste time, lost revenue, and delayed treatment for other patients. I think this is a great fit because value, once again, if you can reduce no-shows, it saves time, improves outcome, and increases clinic efficiency. You know, nobody wants to wait in a doctor's office for 4 hours, 30 minutes, whatever it be. If they can be more efficient, that's better for everybody. Feasibility also, most clinics already collect appointment, patient, and demographic data, making it easy to build a data set, so it's feasible. And learnability. No-show patterns can be learned using features like age, appointment time, and their previous attendance record. So moving to step two, I used CRISP-DM for business understanding. The business goal is to reduce no-shows by identifying at-risk patients and proactively reaching out to them. The data mining problem is a binary classification task, like will a patient show up, yes or no. We'll measure success in two ways. If I was to do this, it would be outcome metric and output metrics. The outcome metric would be reduced no-show rates. The output metrics would be accuracy, recall, and AUC of our model. So relevant features for this could include appointment day, end time, lead time between scheduling and appointment. Like I said, the patient's age, prior no-show history, the distance from the clinic would be a big one, and the appointment type. Is it a follow-up or is it a new visit? What are we looking for in this appointment? To get into my validation plan, my machine learning solution is a predictive model, such as Random Forest, which I'm a big fan of, or even a XGBoost classifier. To validate it, I'd train or test using the historical data that I talked about us having, and then I would run an A/B test. One group gets our usual reminders, the other gets personalized alerts based on their predicted no-show risk. And then we would compare the rates, the no-show rates across both groups to evaluate the real-world impact of this system. And through each iteration, it would be iterative, it would help us improve model performance and outreach effectiveness. So as far as the machine learning system design, there are three key decisions here. One would be batch versus real time. I would use batch predictions generated daily. That's sufficient for next day appointment prep. Number two would be manual versus automated retraining. I would retrain manually every quarter to monitor for drift and maintain simplicity early on. You want to keep it simple as possible. And number three, deployment architecture. I recommend a cloud-based deployment, using AWS or Azure. This would allow us to integrate with SMS and email services easily and scale over time. So, lastly, there are some production risks. One would be data drift, as I mentioned. That's why I said manually. Patient behavior may change over time, especially with new policies or telehealth. So I'll monitor, key features regularly. Concept drift, the definition of a no-show could change. Do virtual visits count? We're going to count them differently. Annual reviews with our stakeholders would help with that. And then lastly, training serving skew. So if a live appointment data changes after we generate predictions, it may cause errors. So I would mitigate this by snapshotting inputs daily. By doing this, we would be able to mitigate that risk a bit. So in closing, I just want to say, I believe this project addresses a real and costly problem, and I used machine learning here to figure out this problem or think about this problem. And if we were thoughtful, with this and validated and monitored it, I believe the system could reduce no-shows and improve healthcare delivery. I really appreciate your time, and thanks.